Welcome back to Math 103. This is video number 17 on measuring power. Last time we were looking at finding the Shapley-Shubik power distribution based solely on a complete list of winning coalitions. Well, here are all 24 sequential coalitions with the pivotal player underlined in each one. Now, we last time looked at the technique for going sequential coalition by sequential coalition and finding the pivotal player in each one. But after working with this collection of winning coalitions, you might start to have an intuition about how this works that gives you a little bit of a shortcut when finding the pivotal player. So notice that all four possible three-member coalitions are on the list of winning coalitions. In other words, any three players, it doesn't matter which three, can put their yes votes together and pass a resolution. There is, however, only one two-member winning coalition on this list. So what does this mean? It means that if you've got A and B, or B and A starting out a sequential coalition, then whoever's second is going to be pivotal. But that's the only time you have the second person in a sequential coalition be pivotal, because this is the only way you can have a two-member winning coalition. The rest of the time, it's the third member of the sequential coalition who is pivotal. So here, it's the third member of the sequential coalition. Here two, here two, here two, here, here, and all of these, and all of these. So it never takes until the fourth person to find a pivotal player, because it never requires more than four people to actually pass a resolution. Right? Any three can get the job done. Okay, so there is no one pivotal in the fourth position. Usually the pivotal player is in the third position, with the exception of when you start out AB or BA. Tallying up all the instances of pivotality, of which there are 24, so the denominator is certainly, we know in advance, going to be 24 for each player's fraction. Well, A has 8 instances of being pivotal out of 24 sequential coalitions, and that's a third of the time, or 33.33% of the power. For B, it's the same thing, 8 24ths. For C, it's only 4 times being pivotal out of the 24 total, and for D also, it's 4 times out of the 24 total. When you look at these percentages, it turns out this is the exact result, exactly the same numbers, exactly the same power distribution that we obtained using Banzhaf's approach. Okay, so this can happen. It's by no means guaranteed to happen. Most often, Banzhaf and Shapley-Shubik will differ at least a little bit in the exact numbers that they produce. Here, they happen to be precisely the same. Since we have the same numbers as in the Banzhaf version of this problem, we reach the same conclusion that A has twice as much power as D. For every 8 units of power that A has, D has only 4. Okay, so 8 divided by 4 equals 2. Now earlier we examined a simplified version of the UN Security Council, in which there were 4 member nations that we called W, X, Y, and Z. In that example also, we did not have a quota and weights to work with as such. Instead, we had a verbal description of what was required in order to pass a motion, for the council to pass a resolution. So each council member has 1 vote, and a majority of votes is required in order to pass a resolution. Right? So in other words, there are 4 members, and at least 3 of them have to vote yes. So that's 1 requirement. But there's another requirement, and that is, we're told that W and X have veto power, which means that in order to pass a resolution, both W and X have to vote for it. Okay? To say that W and X have veto power does not mean that, well, one of them has to vote for it. No, both of them have to vote in favor in order for the resolution to pass. Okay? So we have 2 constraints here, and we reasoned out that the complete list of winning coalitions consists of all the players, or 3 of them, but not Z, and so the veto power players together with Y, or the veto power players together with Z, but excluding Y. Right, so there are only 3 different winning coalitions on our complete list. Once we have that complete list, we can use the same technique as in the previous problem to figure out who's pivotal in each sequential coalition, of which I happen to have picked 3 to display here to illustrate the technique. So we ask, is W alone a winning coalition? No, W alone is not a winning coalition, so W is not pivotal. How about W together with X? Well, they are the veto power players, but just the 2 of them are not enough to pass a resolution. We really need a 3rd player. How about Y? Now when Y arrives on the scene, now we do have a winning coalition here, and that makes Y pivotal. How about the next example? Y, then X, then Z, then W. Well, Y votes yes, not enough to pass the resolution. X joins in, still not enough to pass the resolution. Z joins in. Well, now you do have 3 players, but XYZ is not on this list because W has to vote yes before anything can pass. So W's arrival, and only W's arrival, is enough to create a winning coalition. Finally, WZXY. W votes yes, not enough. Z joins in. W and Z are still not a winning coalition. WZX, yes, that's the same collection of members as WXZ, so with the arrival of X, we have a winning coalition, and therefore our pivotal player. We can proceed to carry this out for all 24 sequential coalitions and find the Shapley-Shubik power distribution. Now, it's worth noting here, just as we did in the previous example, that there is a conceptual shortcut that we can find if we understand just what it takes to be a winning coalition. For example, there are no 2-member winning coalitions in this example, therefore the second person is never going to be pivotal in any of these sequential coalitions. There are no dictators either, so the first person is certainly never going to be pivotal in any sequential coalition. That leaves us with the 3rd and 4th positions as the only places where someone could possibly be pivotal. Now, if you get up to the 3rd position in a sequential coalition, and both of the veto power players have already joined in and voted yes, or if, as of that 3rd position, they've both joined in and voted yes, as in this example, then the 3rd player is pivotal, because by the time you have 3 players, and those include both veto power players, that's enough to win. However, if it takes until the 4th position, until both veto power players have arrived, whether that last one is X or that last one is W, if it takes until the 4th position for both of the veto power players to have arrived, then it must be that that 4th player is the pivotal one. Nothing can pass until both veto power players have joined in and voted yes. Putting it all together, we find that according to Shapley and Shubik, W has 10 out of 24 instances of being pivotal. X also has 10 out of 24, so they each have 41 2/3% of the actual power. Y has only 2 out of 24 such instances for 8 1/3% of the power. Z also has only 2 out of 24. Now, our last question is how much more powerful W is than Y, or how much more powerful W is than Z. In general, how much more powerful is a veto power player than a non-veto power player? So we can just compare any one veto power player to one regular player. It doesn't matter which ones we use. All right, now Banzhaf's approach had already answered this question in a certain way. Banzhaf had already concluded that a veto power player had 3 times more power than a regular player. Well, what do Shapley and Shubik conclude? They come to a somewhat different conclusion. They agree with Banzhaf that it's a lopsided situation, but they conclude that it's even more lopsided. Right? So they conclude that W is 5 times more powerful than Y. That's because the ratio of how many instances of exercising power W has to how many instances of exercising power Y has, 10 to 2, that's 5. W is 5 times more powerful than Y. That same statement applies to either veto power player in comparison to either regular player. So this is nothing new for us, that we have 2 different approaches to measuring power. They agree on a general level that a veto power player has several times more power than a non-veto power player, but they differ on the details of just how many times more power.